ahead and do the factoring in the math knowledge question, and then once everyone has finished, you can unpause the video, and I'll show you how to do these. So on the factoring, you're going to start off by factoring out a 3 and an a, and you're going to have 216 plus 343a cubed. And then from there, we're going to do our sum of cubes. So hopefully you remember that formula. You're going to have 6 plus 7a, and then 36 minus 42a plus 49a squared. And so that's how it would factor. Now for the math knowledge question, it asks for the volume of a cube whose sides measure 4 in length. The volume for a cube is just going to be 4 cubed because the length, the width, and the height are all the same value. They're all 4. So 4 cubed is 64. So D would be your answer. Okay, so we are looking at lesson 76 today. Functions of negative x, functions of the other angle, and then rules of the game. So hopefully you'll understand a little bit more about these concepts after the lesson. Graphs of even functions are symmetric about the y-axis. Y'all see how this graph is symmetric about the y-axis? Whatever function this is would be an even function. Okay? Graphs of odd functions are symmetric about the origin. And I'm going to show you. I clone this. And then I take it and I flip it 180 degrees. You see how it looks the exact same? That is an odd function because it's symmetric about the origin. You turn it 180 degrees and you have the same exact graph. Sine is an odd function. If I clone it and I rotate it 180 degrees, y'all see how that's the exact same function? Sine is an odd function, okay? Cosine is an even function. If you look, it is symmetric about the y-axis. So cosine is an even function, sine is an odd function. That comes into play whenever we have functions of negative x or negative theta. The sine of negative theta is the same thing as negative sine theta. Likewise, the cosecant of negative theta is the same as the negative cosecant of theta. The negative on your angle can just get moved out to the front. So if you had the sine of negative 30, that is the same thing as the negative sine of 30. If you think about this, negative 30 degrees is in the fourth quadrant here. Sine is negative in the fourth quadrant, so when we find the sine of 30 and then we negate it, we found the same value. And that'll hold true for any value of theta. You'll need to memorize those. Cosine of negative theta and secant of negative theta are a little bit different. What happened? The negative just disappeared. So on cosine and secant of negative theta, you can just drop the negative off. And that's because cosine and secant are positive in the fourth quadrant. They have a slightly different sine value in the different quadrants, and so cosine of negative theta is just equal to cosine of theta. And that's true for any quadrant when you're dealing with cosine and secant. Now tangent of negative theta and cotangent of theta would be negative tangent of theta and negative cotangent of theta. So on that one, the negative goes from your angle out in front. So the two that are different are cosine and secant. Sine, cosecant, tangent, and cotangent all take the negative from the theta and put it out front. Secant and cosine are the only two that the negative just disappears. You'll definitely want to memorize that information. Okay, so now looking at functions of the other angle. Hopefully you remember that if the sum of the two angles is 90 degrees, then the angles are complementary angles. So 90 minus theta is called the complement of theta. because 90 minus theta plus theta, those equal 90 degrees. If you look at our triangle here, the sine of theta is A over C, opposite over hypotenuse. The cosine of 90 minus theta is also A over C. I don't know if you've ever realized that before. I'll show you something. The sine of 30 equals the cosine of 90 minus 30, which is the sine of 30 equals the cosine of 60. I don't know if you've noticed that, but that's always going to be true. The sine of theta equals cosine of 90 minus theta. Likewise, the cosine of theta equals the sine of 90 minus theta. Okay? That can be used for tangent and cotangent. Tangent equals cotangent of 90 minus theta, and cotangent of theta is the tangent of 90 minus theta. Those are the same. And then the same can be said for secant and cosecant. Now notice that they are paired differently. Sine is not paired with cosecant on these sets. You will also need to memorize these 6. Okay? So the sine of theta is cosine of 90 minus theta. Those are the same thing. So now looking at the rules of the game. You can substitute an equivalent expression for any part of a given expression. You're also allowed to multiply the top and bottom of any expression or the top and bottom of any part of your expression by the same non-zero quantity. And then you can combine terms that have equal denominators. Okay, so those are your rules. So these are show that's. We want to show that cotangent of x over cosecant of x equals cosine of x. So on these, I have a very specific way that I want you to do them. In order to do a show that, you need to pick a side, either the left side or the right side. It doesn't matter to me which side you pick, but you've got to pick one. Obviously, on this one, you can't really simplify cosine of x. So you want to pick the left side because that's the one that you can simplify. 97% of the time, you're going to want to pick the left side. Okay? So we're going to start off by rewriting whichever side we picked. So you're going to write it exactly as it appears in the problem. And now, the next thing that you have to do is to simplify. And you have to show each individual step. So I hate to use the word proof, but it is kind of like a proof where you have to show all your steps. But all you're doing is going to be replacing things and simplifying. Okay? So instead of cotangent, what can we say cotangent is? I could say that it is 1 over tangent, but then I'd have to replace tangent with something. Cotangent is cosine over sine. Because tangent is sine over cosine, so the reciprocal of that would be cosine over sine. And then we know that cosecant is 1 over sine. So now we can say cosine over sine times the reciprocal, so sine over 1. Then your sines will cancel, and you're left with cosine of x. Well, if you look, isn't that what they give us right here? It is. So you check it off, and all of this would be your work. Okay? So all of that would be your work there. Sometimes you'll be able to fit that on the test. Sometimes you can put it on the back. But that's how you would do a show that. So let's look at another one. Show that sine of x times cotangent of x equals 1 over secant. So again, the side that we're going to want to pick on this one is the left side, because all we can really do to the right side is make it cosine, because 1 over secant is cosine. So you start by writing the left-hand side down, because that's the side we're going to work with. Now, sine can't really be simplified or rewritten. We want to rewrite cotangent. So cotangent is cosine over sine. And so now we can simplify by canceling out those signs, and I just have cosine. But that's not what I have over here on the right side. But cosine does equal 1 over secant. And so now that it equals this, I have my answer. So you have to keep manipulating one side until it equals the right. You can't solve both sides at the same time. You only work on one side of your equation. Okay, so let's look at one more. We have cosine of negative theta times sine of 90 minus theta equals cosine squared. So the left side is the one we're going to want to work with. So we're going to start by writing it down. And now we're going to use those parts that I told you we're going to need to memorize. So what is the cosine of negative theta? Well, if you look back, the cosine of negative theta is just the same thing as cosine of theta. And then what is the sine of 90 minus theta? Well, if you look back, the sine of 90 minus theta is the same thing as just cosine. And so cosine times cosine is cosine squared. And that is what we have right there on the right. So this would be our answer. So these are called show that's. This is the first lesson we've had where we've dealt with show that's. We'll have other lessons that will add show that's, add stuff to our show that's. So you want to make sure that you practice these. Don't just skip them. You do need to definitely practice them because they are going to get a little bit longer to show that each side is actually equal to each other. Okay? And you will always have that it does work. You won't ever have that, no, what you gave me does not actually work. The equation they give you is true. Okay? So make sure that you do your homework tonight, 1 through 30, so that we can go over any questions you have tomorrow.